Hello friends, good afternoon and welcome dear friend to CEC live lectures. Dear friends, today in computer science we will talk about the concept of relational database model and entity relationship diagram. To discuss this topic we have with us our subject expert Dr. Pavitra Bharadwaj. Dr. Bharadwaj is assistant professor in Department of Computer Sciences, Jesus Mary College, University of Delhi. Without further ado, I would like to welcome ma'am to our studios and request her to start the lecture. Welcome ma'am.
So, today we are going to talk about a very interesting topic related to the database concepts. This is relational database model and entity relationship diagrams. But before we begin on this topic per se, I would like to talk about a few basic concepts, few basic definitions, or maybe a quick revision of the concepts of what is database, what is a DBMS, and so on and so forth. So, what is database basically? A database is actually a logical collection of interrelated records. It is an organization of interrelated records. Like for example, we have a company's database where all the data or records which are stored are related to one particular company. Similarly, what is DBMS? A DBMS or a database management system is a collection of programs that enables user to create and maintain a database. So, basically DBMS is the software, it is an application software which helps the user to access, to retrieve, to create a database and to ask queries from the database so as to give the desired results to the user. So, DBMS is basically an application program, it is a category of application programs which helps to create databases, to manipulate the databases, the data in the databases, to ask queries to the databases and all these. Now, different models of databases are there, one of which is the relational database model. But before we come to the relational database model, we should know what is the purpose of a database. The basic purpose, or why do we actually need a database? So, the database is needed for easy handling and data management. It provides a central store for data with multiple user access. Multiple users, if they want to look at a data item, this is only possible if you use a database. In file system, it is not possible. Then it also provides multiple views of the same data. The same data can be viewed by different people according to their authorizations and privileges using a database management system. A view is actually a virtual view of the table or a virtual table which is created to support the user's requirements of data. Then redundancy or duplicacy of data is controlled because to a great extent data is stored at one single place only. Unauthorized access to the data is restricted to a large extent because all users are provided with their login IDs and credentials, and these login ID and credentials, they also define what extent or what view the data or the user is going to get. So, unauthorized access is controlled. Then it also provides a very important feature in controlling the backup and recovering the database in case of failure. So, the loss due to failure is reduced to a great extent. Then enforcing integrity constraints. Now, what actually integrity constraints are will be discussed in the due course of the lecture, but basically these constraints are imposed to maintain the consistency and to keep the data in an integrated form all the time. It also provides concurrency control system so that in case of simultaneous access of the data items, the database becomes consistent and the users get the correct value of the data. No matter how many users are accessing the data item, the value at any point of time will be consistent and correct and accurate. Now we come to the relational model. Basically, the relational model is a logical model which allows a person to view the database in the form of a logical structure. The relational database is perceived as a collection of tables. A table is basically a two-dimensional structure which has some rows and some columns. There are multiple tables in a single database and these tables are related or associated to each other. Each table holds the data about a specific entity of the database. Now, the tables are often connected to each other through shared or common attributes, and the relationship amongst the different tables is known as the relationship schema. A table basically yields complete structural and logical independence. Now, when we talk about a relational database, the database management system which is used to manage this type of database is known as the RDBMS, that is Relational Database Management System. A relational database basically holds multiple types of objects. Other than tables, it has queries, forms, reports, macros and other objects also. Tables, we know they are the two-dimensional structures where the data is held. Queries will provide, the platform will provide a channel to the user through which he can ask questions from the database, retrieve data from the database depending on his requirements, his conditions. Forms provide a user interface to the database so that the user can put in or can feed in his own data. So, forms will provide a data entry interface to the user. Then the database management system will also provide the facility of generating reports. Reports are very important because ultimately the user will view the data only through the reports. So, the reports can be customized, they can be filtered, they can be sorted on as many fields as the user wants to do it. So, when we talk about a database, a relational relation, in this relational databases, a table is what is known as a relation. As I just told, a relation has rows and columns. So, the rows in the table are known as tuples, the columns in the table are known as attributes, and a table or a relation always has a name in the database. So, in this example, if one sees, student is the name of the relation, the attributes are roll number, name and marks, and the tuples are the rows 101, Anu 90, 102, Paul 91. So, these individual rows are known as tuples or records. Now, one database can hold more than one table. The table can hold different kinds of data. It can have text data, integer data, date and time type of data, currency or other objects. Data in the tables is linked and the link between the tables is known as a relationship. Now, this diagram here shows the different tables which can be there in any database. For example, this database represents that of a educational institution, maybe a college or university, which has multiple tables like the department, professors, courses and students. Each table has its own attributes or columns, and there are some columns which are common to the different tables. These common columns are the basis for forming the association or the relationship among these tables. So, a table we say is related, that is certain records in the two tables are related, and the real power of the relational databases lies in the fact that these tables are related to each other. The very ability to relate records in multiple tables gives the relational power their relational databases their real power. Now, a very important aspect of relationships is the different types of relationships which can be created which can be created amongst the records of the different tables. For example, there is one-to-many relationship where one record of the parent table is related to multiple records of the other table, but all the records of the other table are related to one single record of the parent table. This relationship can be easily understood with the example of parent-child relationship. For example, all children get associated with the same parent, but the parent can have multiple children. So, one person can have multiple children and each child has a single parent or a single father or maybe mother. So, this kind of relationship is known as one-to-many relationship or parent-child relationship. Then there can be many-to-many relationship. For example, an employee might learn many job skills and each job skill might be learned by many employees. So, employee learns skill. So, in this case, multiple records of the employee table will be associated with multiple records in the skill table. Then there is another relationship called one-to-one relationship, in which one record in the parent table is associated with only a single record in the other table. For example, one manager manages only one store. In this case, if there is an assumption that a manager can manage more than one stores, then the relationship will become one-to-many. But if there is a constraint that a manager can manage only one store, then the relationship becomes a one-to-one type of relationship. So, many-to-many relationships, when implemented practically, they are actually done through creating two one-to-many relationships. In the due course, we are going to understand how this is done with the use of weak entities or creating another table to represent the same. So, this diagram here shows a one-to-one relationship where each record in table A is associated with only a single record in table B. There is only a single line which is connecting one record of table A with another record of table B. So, this type of relationship is known as one-to-one relationship. Another diagram now shows a one-to-many relationship where you can see record 1 in table A is associated with 3 records in table B, record 1A, 1B and 1C. Similarly, record 2A is associated with 2 records 2A and 2B. So, this means that one record in the table A is associated with more than one record in table B. This diagram shows how multiple tables can be related. If a database has 4 tables, then all the 4 tables are related to each other by the use of some common attributes among them. Now we come to defining some important key terms related to the database system. The most important term which is commonly used is known as entity. Now, an entity is any real world object about which data is stored in a database. The entities could be animate objects like student, teacher, bank, branch, manager, employee, etc. Or they could be an inanimate object like job, exam, class, course. These could be an examples of inanimate objects. But the point here is that each entity will be represented within the database in the form of a table. Therefore, a table is often known as a relation or even an entity. So, the database designer will select the different entities in the system that he or she is trying to develop a database for, and each of the entities for which data needs to be stored in the table is represented in the form of a relation or the entity. Then each entity has certain characteristics or properties that define that entity. For example, if we take the entity book, so the properties that define the book will be the ISBN number of the book, the title of the book, the author of the book, the publisher of the book, maybe the year of publishing the book, the price of the book. So, all these properties will define that entity. So, these properties or characteristics that define the entity are known as attributes. Now, the table holds entities or entity sets. These are also called relations. They are comprised of rows and columns. For example, the table here shows the different entities and their attributes. If the entity is student, so the attributes for instance may be student ID, name, course, date of birth, etc. If it is teacher, the attributes will be teacher ID, name, date of joining, department, salary, etc. If it is exam, it could be date of exam, the course or the maximum marks. If it is book, I just discussed, it could be title, publisher, price, ISBN number, etc. So, the terminology which is important to note here is that a table is represented or is known as a relation, the row is known as a tuple and the column is known as the attribute or field. The row is also known as a record and the table is known as a record type. So, the same object could be named or could be addressed using any of these nomenclatures in the database context. Now, we come to keys. Now, key is a very commonly used term in the database dialect. Generally, we talk about keys to define any attribute of the database table. It consists of one or more attributes that determine other attributes. Now, the primary key is an attribute or a combination of attributes that uniquely identify any given entity or row in a table. Primary key cannot be null. For example, student ID, ISBN number or Aadhaar number, all of these fields or attributes are those attributes which will help in identifying the records in a table uniquely. It is very important to identify the records uniquely because no two records in a table can be same. This is a condition to avoid redundancy or duplicacy of records within the table. So, since not all the values of all the fields can be same, therefore, this constraint has been put that one of the attributes will be marked as the primary key. The primary key will be the attribute whose value will always be unique and not null. That is, it cannot be left blank. So, generally a field is chosen as the primary key which has essentially got a value. For example, for a student, the roll number is a field which is essentially not null and unique in the system. Similarly, other fields can be chosen. there are conditions where one single field is not available to be marked as the primary key. In this scenario, what has to be done? The problem is solved by choosing two or more fields together to mark as the primary key. So, when one field is not available to be demarcated as the primary key, a combination of fields or attributes is used to make the primary key. Such a primary key, which is composed of two or more attributes, is known as the composite key, because it is composed of more than one attribute or more than one field. The basic idea of primary key is determination, that is, the value of the primary key can be used to determine the values of the other fields of the table. If you know the value of the primary key, you can find out the value of all the other attributes of the table, which is not the case in vice versa. That is, if I give you the roll number of a student, you can easily tell me the name and date of birth etc. for the particular student. But if I give you a date of birth value, you will not be able to give me the roll number of the student with full 100% certainty, because the date of birth value may not be unique for the different students of the table. So, the composite key, as we discussed, is a key which is composed of more than one field taken together. Then there is another concept called the super key. The super key is any key that uniquely identifies each entity. Any attribute or combination of attributes which can be used for identification of records in a table is known as a super key. This example shows a table student which has fields roll number, name, course, marks obtained, fees paid, etc. In this case, roll number is a super key, roll number plus name will be a super key, roll number, name, course will be a super key, roll number, name, course and marks obtained will also be a super key. So, basically what is the difference between the primary key and the super key? The primary key is the minimal super key. Minimal super key means it has the least number of attributes which are required to identify records uniquely. That is, in the student table, only the roll number field in itself is sufficient to identify the various records of the table. You do not require the other fields along with the roll number to identify the records uniquely. Therefore, roll number is known as the primary key or the minimal super key. Then we come to another type of key which is known as the candidate key. Now, there could be situations in a table where multiple keys or multiple attributes qualify to become the primary key or have the virtues such as uniqueness and not nullness, so that they can be also determined as the primary key. In this case, all these attributes which qualify to become the primary key are known as candidate keys. Out of the candidate keys, of course, one is selected for becoming the primary key. Then the other key is foreign key. Now, foreign key is an attribute whose values match the primary key values in the related table. Foreign key basically refers to the two tables that are related to each other. So, when we use the primary key attribute of one table in another table, then it is known as the foreign key. So, the foreign key will be the primary key of another table which is created, which is utilized in another table to create a relationship or an association between the entities. Then another commonly used key is secondary key. Sometimes we witness that when we go for say a health checkup to the hospital and we do not remember the primary key, that is the customer ID or the patient ID. In that case, generally what we are asked for is the mobile number. So, once the mobile number is given, our records can be found out. So, in this case mobile number is the secondary key. So, basically what is the role of the secondary key? Secondary key is only used for data retrieval purposes. It is only used to find out or to search for data in the given table. So, it is that field which may not be unique for the different records, but certainly it will give you 3 or 4 records out of all the records in the table. So, we have discussed primary key, which is a unique and not null attribute. We have discussed foreign key, which is used to create relationship association between the different entities. Then of course candidate key and secondary key. Thank Now we are going to talk about the entity integrity and referential integrity rules. These two constraints are very commonly imposed on database in order to maintain the consistency and integrity of data in the databases. Consistency basically refers to the data being same at the multiple locations where it is saved, and integrity means that the database should always have accurate and correct data which is there in the databases. So, the first constraint is the entity integrity constraint. The entity integrity constraint basically states that the primary key fields cannot have a null value and they have to be essentially unique. That is, all entities within the entity set of the table will have unique entity. They cannot have duplicate values for all the attributes of the table. Then is the referential integrity constraint, in which we say that if table A has the primary key attribute which is being utilized by another table, say table B, then table B can only have those values for the foreign key element, for the foreign key attribute which are there in the primary key column of table A. They can have a null value, but no other value which is not there in the primary key column of the table A or the parent table. This can be explained by a simple example. For example, we have departments English, Hindi and Maths in an institution. So, all the teachers belonging to the college will either be a part of English or Hindi or Maths department. They cannot be belonging to any other department because there are only 3 departments in the institution. What I mean to say here is that the department ID column of the department table is the primary key, whereas the department ID column in the teacher table is the foreign key. So, the department ID column in the teacher table can only have those values which are there in the department ID column of the department or the parent table. They can, if in case we assume that a teacher has not yet been assigned to a particular department, then the value in the department column for the teacher can be null, but there cannot be a value which is not there in the department ID column of the parent table, that is the department table. So, with this it will ensure that all the records in the primary table have only those related records in the foreign key table which have related records in the primary key column. So, this will ensure referential integrity. This can also be ensured further by using the option to cascade updates and cascade deletes. This means that if any updation is made in the data of the primary key column, all the updates will automatically happen in the foreign key column of the foreign key table. And if any record is being deleted from the primary key column, it cannot be done unless all the related records in the foreign table or in the related table have been deleted. So, the database management system will ensure that at all times entity integrity as well as referential integrity constraints are enforced so that the data remains consistent and integrated at all instances of time. This will also ensure that there is no redundancy in the data within the table and foreign key can be referenced the records properly. So, referential integrity is defined as if the foreign key contains either matching values or nulls, the tables that make use of such a foreign key are said to exhibit referential integrity. A foreign key field can have only those values which match the primary key values in the table to which it is related or null values. It ensures that the data in the two related tables is consistent. The data in the primary key column cannot be deleted if related data exists in the foreign key column. This is known as cascading delete. Same happens with updations. If the data in the primary key is updated, all updations will take place in the foreign key or in the related table also. Now, dependency is another very crucial concept related to relational database system. This is related to keys. So, a key helps define entity relationships. So, the key's role is based on the concept known as determination, which is used in the definition of functional dependency. Now, if we say that attribute B is functionally dependent on attribute A if A determines B, an attribute that is part of a key is known as a key attribute. A multi-attribute key is known as a composite key. So, what we are trying to say here is that if attribute B is a non-key attribute and we say that it is functionally dependent on the key attribute or on the primary key attribute, then given the value of the primary key attribute, you can determine or you can find out the value of the non-key attribute. So, the primary key attribute basically determines the value of all non-key attributes. In case where the primary key is a composite key, that is, it is composed of more than one attribute, then the non-key attributes are dependent on the complete or on the whole composite key and not on its subset. In this case, the non-key attributes are said to be fully functionally dependent on the key attributes. So, we have discussed two important concepts. One is A determines B, that is primary key determines the non-key attributes, and the second is that all non-key attributes are fully functionally dependent on the composite key attributes, not on a subset of these attributes. Now, this diagram here represents the simple relational database where we are showing two tables. First table is product table where the primary key is the product code. The second table is the vendor table where the primary key is the vendor code. In this case, the vendor code has been used in the product table. Therefore, vendor code, which is the primary key of the vendor table, has been used in the product table as foreign key. Important thing to note here is that the vendor code column of the product table will only have those data items or only those values which are there in the vendor code column of the vendor table. If the values do not match, there is the violation of referential integrity constraint, and hence the database management system shall not allow that further. Now, we come to the concept of ER diagram or entity relationship diagram. Now, ER diagrams basically give an conceptual view of the database. Developing a database without an ER diagram is like building a house without a plan. We think that it is doable by simply laying a brick one over the other, but the moment somebody else takes the responsibility of the project, then the project may completely fail. Therefore, it is very important to have a conceptual diagram before actually building a database. So, this model or this diagram will help the database designer and the future database designers to develop the model as per the plan. So, ER diagram model allows us to sketch database designs. ER diagram model is basically a graphical tool. ER model is widely used in database designs. It is a graphical representation of the logical structure of the database. ER model is a model that identifies the concept of entities that exist in a system and the relationship between those entities. So, in the ER diagram basically specific graphical tools and symbols are used, and to using those symbols and tools, the database designers create a complete logical picture of the database that is going to be developed. So, it will show all the entities which have been identified by the database designer, the relationship amongst those entities, the attributes amongst belong to each of those entities. All these aspects related to the database are put on paper using graphical symbols and which give a comprehensive picture of what the database is going to look like, what has been the interpretation of the database designers from their discussions of the prospective users of the database. Now, basic purpose of an ER diagram is that the database designer gains a better understanding of the information to be contained in the database through constructing the ER diagram. It serves as a documentation tool and it is used to communicate the logical structure of the database to the users. So, basically it is a method or it is a tool which will facilitate to communicate between the database designers and the users. It shows the understanding of the database designers about the requirements from the database that the user is expecting, the desired outcomes that the user is expecting. It is a very important documentation tool which will be used by further people in future who take over the charge of designing the database, updating the database, or even modifying or changing the database in future periods of time. Now, when we talk about an ER diagram, there are three important constructs that we talk about: entity, attribute and relationships. Now, we have also discussed these same constructs in the context of relational database systems. Now, these are almost very similar here also. Now, the picture here shows the different symbols which are used to show the different objects in the ER diagram. For example, the rectangle is used to show an entity. The double rectangle is used to show a weak entity. A weak entity is basically an entity which is existent dependent on another entity. That is generally created when we have a many-to-many relationship in the database. So, then one table is further divided and created two tables, so that one of those tables will have a weak entity and there will be two one-to-many relationships instead of a single many-to-many relationship. Further in the diagram we see that a diamond shape is used to show the rectangle, a double diamond is used to show the identifying relationship or the relationship which is important, then an oval is used to show the attribute, an oval with an underline is used to show the key attribute or the primary key attribute, a double oval is used to show a multi-valued attribute, and an oval with further smaller ovals connected to it is used to represent a composite attribute. Now, what is a multi-valued attribute and what is a composite attribute, we shall be discussing in short while. Then further, a dotted oval is used to show derived attribute. Then this small pictorial representations show the total participation of entity E2 in the relationship. Then the next relationship shows a one-to-many relationship where n represents many. Cardinality ratio is 1 to n for E1 to E2 in relationship R. The other representation could be a min-max representation which shows the structural constraint on participation of E in R. That is, how many records can minimum and maximum number of records from the entity E can participate in the relationship R. Now, we take the formal definition of the term entity. So, an entity can be a real world object, either animate or inanimate, that can be easily identifiable. For example, in school database, student, teachers, classes, courses offered can be considered as entities. All these entities have some attributes or properties that give them their identity. Entity set is a collection of similar types of entities. An entity set may contain entities with attributes sharing similar value. For instance, a student set may contain all the students of a school. Likewise, a teacher's set may contain all the teachers of a school from all faculties. Entity sets need not be disjoint. So, basically a table which shows all the records of the students in the school is the representation of the entity set, and individual records of each student represent an entity instance. So, all the entity instances in the system are clubbed together to form an entity set or a relationship. So, different entities have different attributes, like employee will have name, father's name, etc. Then if furniture is the attribute, then it will have the cost purchase or type or make and so on and so forth. So, different entities, they have different attributes. Now, entities are represented by means of their properties called attributes. All attributes have values. For example, a student entity may have name, class and age as attributes. There exists a domain or a range of values from which an attribute can obtain its value. For example, if I say name, so the attribute name will have a domain of all upper and lower case English language letters, because a name cannot have numbers or any kind of special characters. If I say age, then in general the age domain will be from 0 to 100 years, assuming that the humans have an age of up to 100 years. So, each attribute can have a specific domain, which is the permissible set of values that the attribute can have. The DBMS also allows us to put a restriction on the domain of an attribute. That is, the database user can enforce a rule, can create a rule which will allow only a specific range of values to be given for a particular attribute. For instance, in a company, the rule could be levied as that the salary cannot be less than 10,000 or more than 10 lakh. So, in that case, the domain for salary will be 10,000 to 10 lakh. So, there can be multiple attributes which have the common domain. Now, there are different types of attributes which need to be discussed. The first is simple attribute. Simple attributes are atomic values which cannot be further divided. For example, a student's phone number is an atomic value of 10 digits. A composite attribute are attributes which are made up of more than one simple attribute. For example, a student's complete name may have first name, middle name and last name. Or address. Address is an attribute which is composed of house number, name of the street, name of the locality, name of the city, name of the state, name of the country and PIN code. So, it becomes a composite attribute which is composed of several other attributes. Then we have derived attributes. Derived attributes are those attributes that do not exist in the physical database, but their values are derived from other attributes present in the database. For example, average salary in a department is not saved directly in the database, but it can always be derived from the salary attribute of the employee table. Similarly, age is an attribute which is not stored in the database, but date of birth is used to derive the value of age within the database. Therefore, there are several attributes whose values can be calculated from the existing attributes within the database. Thus, there is no need to store the values of these attributes and they remain there as derived attributes whose values are computed as and when the user requires those values. Then we have other types of attributes like single valued attributes which contain only a single number. For example, the social security number, or in our case the Aadhaar number, those whose value is only 1. Whereas, we can have multi-valued attributes which may contain more than one value. For example, a person can have more than one phone number, more than one email address, etc. So, there are single valued attributes which are used in the ER diagram, and there are some multi-valued attributes also which will allow the user to store multiple values for a given attribute. Next, we come to relationships. The association among entities is called a relationship. For example, an employee works at a department, a student enrolls in a course. Here, works at and enrolls are called relationships. Now, a relationship set is a set of relationships of similar type. Like entities, a relationship too can have attributes. These attributes are called descriptive attributes. When we talk about relationships, there are a few aspects related to a relationship that need to be discussed, like the degree of relationships. The number of participating entities in a relationship define the degree of relationship. That is, how many tables are associated through this single relationship. If it is a binary relationship, the degree is 2. If it is a ternary relationship, the degree is said to be 3. So, the number of participating entities define the degree of the relationship. Another important concept is cardinality. Cardinality defines the number of entities in one entity set which can be associated with the number of entities of other set via relationship. That is, if there are 2 tables which are participating in a relationship, then how many entities of first table are related to how many other entities or records in the second table or in the other related table. Cardinality has been defined as 1 to 1, 1 to many, many to 1 and many to many. We have discussed these type of relationships earlier also within our lecture. So, this last diagram will show a small picture of an ER diagram which represents 2 entities, employee and department. An employee is assigned to a department and an employee manages department. So, this relationship shows 1-to-1 relationship between employee and department and a many-to-1 relationship between employee and employee working in a department. We shall continue on this in the next session. Thank you.
Dear friends, we hope that today's lecture you were able to understand the concept of relational database models and entity relationship diagrams. On that note, we would like to thank Dr. Pavitra Bharadwaj for coming here and delivering this wonderful lecture, and thank you dear friends for watching our lecture. Stay tuned and keep watching. Thank you.